Uno, dos. All right. All right, good morning, everybody. Morning. I have Groot saying good morning to you, Groot. All right. Is that real or not for some of you? Yeah, it's true. It's true. It's a good point. All right, my name is Luis Majano. Introduced myself yesterday, computer engineer by trade. I want to thank Giancarlo Gomez. We worked together a lot with this presentation and a lot of fixes with all the stuff that we're going to show you today. So, who here loves scheduled tasks? A little bit. Who hates them? Who loves and hates them? Yes. This is so true, right? We love when we can automate things, right? My friend over here is an automation machine, but there's always a hate component to it, right? So we'll kind of venture into some of these directly. What are the pros and cons about using certain things? Obviously, we use at Ortus pretty much every single CFML engine, a lot of languages, right? And we've been able to deal with this with a lot of ways. And let's look at the pros, for example, starting with Adobe CoFusion, right? They've added configured cron expressions, which is familiar to some people or some DevOps that are used to working with cron. Ability to group scheduled tasks, ability to create and modify actions, some type of modes that were introduced to give you enterprise scheduling at the application level or the whole engine. They introduced event handlers, very simple ones, granted, just for exception on completions. On Misfire really doesn't work, so maybe I should remove it actually from there. But there's also cons too, right? They've done this since the initial versions of Adobe CoFusion. Great. The core features really come at a hefty price because obviously of enterprise, right? But you pay what you get. You can track a little bit of things in code, right? Tasks can be created, they can be edited, they can be removed at a certain point, right? But it has its benefits and it has its bad things, just like with anything, okay? Let's look at Lucy now, right? Another client comes and I have to deal with him or her as well on this, right? Pros. Unique execution, right? There's no overlaps. A little bit of funny behavior. I have to talk, Misha, about the fully interval on the remaining ones, right? No edit or delete allowed in the administrator, right? No way, nice way to force code only in workflow, right? Auto delete helps with, bad habit of people, right? Not being about code and cleanups, right? So there's all the benefits that we had with Adobe are reflected here, but a few more, right? There's also some cons, right? None of the advanced features, obviously, that you pay for in ACF, like application level tasks, no event handlers. Tasks under 10-second intervals do not fire. I do not understand. That was reported a few days ago. So very interesting. Access to the web administrator or the server administrator can be a bit of a pain, right? So still pros and still cons, right, of the ways that we have to interact with it. There have been other ways in other languages. How do we deal with this, right? So we go to external runners, right? Such as using cron, right? Jenkins, GitLab. So who used external runners for scheduling, right? Again, you also get pros and cons, right? What are the benefits? Well, some give you a dashboard, right? Provide a nice UI for visualization. You might not see everything, but it gives you enough, right? Complex scheduling, sometimes it does allow you for complex scheduling, triggering, right? If this action happens, trigger the other one, etc., right? Interaction, I think that one was a big one for us in some projects, right? Ability to run, stop, pause, delete, etc. Excuse me. Centralization was another big one, especially when you have small teams doing DevOps, right? How can you make your life as fast as possible and efficient as possible? Centralization of these tasks into one location was important, right? So that was a big pro. But you also have issues as well, right? No developer visibility sometimes. The DevOps are basically saying, get away, do not touch this, right? Yet another system to maintain, right? More logs to traverse and make sure things are logged in order to find out what happened. And now that we're decoupled from the engine, right, now we have to go only through HTTP or HTTPS, right? So we have to make sure that we can access those tasks, right? So hard to track sometimes the exceptions. We have to look in both places, right? We have to go to the CFML engine to actually look for an exception. Maybe the actual Jenkins provider is the one that failed, right? So there's intricacies here, right? How we're going to deal with security, right? Are we just going to obfuscate our URLs and hopefully nobody's going to find them, right? Are we going to be creating API keys, right? Some type of JSON web token, or we don't care and just public URLs, right? So all these are pros and cons of the decisions that you make as an engineer, right, to solve one problem, which is scheduling, right? So there are several pain points with scheduling, right? Like my friend over here, right? There are several pain points, right? So limited scheduling capabilities is a pain point, right? You want to get more complex. Sometimes things always start very simple, but they get complicated as things grow and have a life. Limited error handling, that's a huge one. Obviously, we always make mistakes, right? How are we going to deal with this, right? Hard to cluster, right? Where most of the time it would be great if we only had one server forever to deal with, right? But sometimes we work on thousands of servers, thousands of instances, right? How do we manage that, right? Each CFML engine also has different configurations, right? What if we need to work on both, right? How are we going to handle that, right? External scheduling sometimes isn't portable, right? I can't contribute runtime additions to scheduled tasks, right? And usually based on public-facing endpoints, right? Definitely not type of object-oriented. I don't have any type of design patterns available to me at that point. I just have the server and client request at that point, right? So definitely not functional. So all of these problems, right, are there. But for us, what we found is the biggest pain point was if managing code, switching an engine requires refactoring based on features and attributes, but if it's not managing code, it's really painful, right? We had a project with over 150 scheduled tasks split over different servers, right, with no pattern, people writing them in different ways, managing in different ways. Sometimes they're firing. You're like, who the hell fired that task, right? Where is this task running, right? So this was, to us, the biggest pain point. So like with anything, right, when you have a problem, you have to innovate, right? So we did. So we released on the left-hand side of your site, callbox or box scheduled tasks, right? And we're gonna go through them. And we did this because of these problems, right? Now, very important thing, it works great in callbox. If you're not using callbox, no problem. That's why you have the 3 other options on the bottom. As long as you use some type of box product, you have them available to you. So this is not only for a callbox framework, you can use this in Framework 1. We have clients that use it in Framework 1 that even use it in a Mach 2 app, right? It doesn't matter. As long as you use Wirebox or Logbox or Cachebox, they're available to you, okay? And now we also ported them to Boxlang, so they're available as well. So what are they? So it is a programmatic and a fluent approach to tasks. It is contained within a scheduler, CFC, or BX class. There is no external scheduling. It's all done through the JVM. Built-in lifecycle methods, exception handling, built-in logging, built-in clustering. You do get advantages if you are in the callbox ecosystem, right? You get ability for modularity or hierarchical modules. So every module can actually have its own one or more schedulers that it can manage. You have environment constraints. So callbox is environment aware, so you get that advantage. Caching, you have also the full caching layer available, and much more, right? But like I said, this is available for everything, right? If you want to just use scheduled tasks, just install Wirebox, right? And you have the ability to do that there. And it's all in the docs, right? Or even if you don't use the dependency injection framework, you just do logging, because you just need logging of the scheduled task. Just install Logbox, and all the scheduling will be available to you. And everything that I show you here translates to Boxlang as well. It's all available there as well for any, of course, class. You can see a hierarchical approach here, where you have every module being able to contribute different executors and different scheduled tasks. You code first, okay? You're going to be using source control for your scheduled tasks. It is based on your workflow, right? It makes it easier to manage, easier to track and understand why a task exists. It's really, we really wanted to make it fresh and programmatic and really human in the sense of scheduling the tasks, not cryptic at all. We wanted to make sure that if somebody came in and read it, that they would understand what's going on. That was hugely important for us. We also wanted complete control over the life cycle. Okay? This means the full life cycle, better event handlers, being able to listen to everything that's going on inside of a scheduled task, because they're asynchronous, right? We need to be able to debug them. We need to be able to know what's going on inside of a task. Tasks are also testable, and this was huge for us for code quality. If somebody wrote a task, it has to be tested, right? And now you can test it. Not bound to any CFML engine. Like I mentioned before, we do a lot of consulting. It doesn't really matter what they give us. We want to make it work, right? So this had to be portable no matter where it ran. It adapts itself. So it gave us this limitless opportunities to be able to finally starting to bring some sanity to scheduling. So how does a scheduler look like? Well, first of all, in CodeBox, it has a convention. You put it inside of the config folder as a scheduler.cfc or bx. It's a very simple component or class. In standalone mode or Boxlang, you put it anywhere you want. And it gives you an automatic inheritance, right? It will decorate your object at runtime. You have one method called configure, and inside of the configure method, you will basically be placing all of your tasks. Now, just by the mere fact that it is a class and a component, now I have more design patterns. I can have base schedulers, right? I can basically create schedulers by hand. I have access to my entire engine now, right? I don't have to be relying on just HTTP and HTTPS. So configure is where you declare those tasks. So what can I do with these tasks? Well, we have many frequencies available to you, right? So these are easy to understand frequencies, so you can schedule your tasks. From the every method, you give it a period and a time unit. So you can say every 5 seconds, every 10 minutes, every 1 day. You can use natural words, so you can say every 1 second or every 30 seconds, right? If it's plural, singular, we'll work with that. We want it to be readable, right? So you can say every minute, like that. Or you can say every day. You can say on first business day of the month at a specific time. You can say on Saturdays. You can say on Fridays. You can say on weekends, on the last day of the month, right? So everything that is natural and can be expressed, there's a function for it. It prevents stacking, right? So it allows to force a task to have a fixed delay when starting and when it finishes. And you have also the ability to be able to chain them, right? One after the other, or with overlaps. You can also delay the executions. So you say, okay, I want the scheduler to start, but I don't want any scheduled task to start maybe after 10 minutes after the application runs. No problem. You can delay it. And you just say basically, hey, delay for 10 seconds. Delay for 10 minutes, etc. Create one-off tasks. There's also great. Maybe this is not scheduling. This is just, hey, when my server starts, when my application starts, I want you to warm up my cache. I want you to basically go execute these things, put everything into the cache, we've used it to register with control planes. These are all our mini clusters. They basically talk back to a central location. That's all done through a task. Initial data collections, you name it. You can do that. Lifecycle methods were important, of course. We have the capability to listen to many things. We'll go through them. Such as after a task completes, before a task completes, when there's a failure, when there's success. And you can do it globally for every task that's running or for one specific with a narrow focus. You can do constraints, and this was very, very important. You can do a truth test. You can say when and pass an expression to it. That expression could be any CFML valid expression as long as it provides to be truthy or falsy. Okay? You can also pass a closure or a lambda, and the result will be a truthy or a falsy expression. And then that basically delays the execution of your constraint at runtime. And that was hugely important for some of our schedules. We wanted to make sure that they ran only when this constraint at runtime was truth. Right? Start date and end dates, we all needed that, especially for our marketing teams that needed promotions to run from one specific date to another specific date, and the specific time as well. So you could restrict it to dates and times. Environment, this was also very important for our Callbox apps. Again, this can be very easily done with the when expression if you're not in Callbox, right? But it was important that in staging, that we're not emailing a lot of people or doing a bunch of stuff. We can basically say for our scheduled tasks that are on the staging environment, only run this. So now you could express that. So I'll take you through several examples. If you've never done this before, this is the way you do it in Adobe, right? You do a CF schedule task, and you give it some actions, groupings, tasking, intervals, the event handler if there's anything happens, if this is at the server level or at the application level, and what URL you're going to hit. It's pretty much looks the same in Lucy, right? You have the action, the task, the interval, the start date, the start time, which are not available on the left. Excuse me, URL, uniqueness, and read-only. And we start getting into more of the fluent expressions, right? You name a task, you give it a call expression. This is a lambda or a closure. In this case, I'm running an internal event that is completely inside of my application, no external HTTP URLs, and I say run every 5 seconds. More examples, right? I can say, hey, I want to declare a task. It's going to be clear unregistered users. Call, what am I going to do in my call? Okay, I'm going to get an instance of a user service and call the method clear recent users. That's my task. Every day at 9 a.m. That's it. That's how you register your task. Here's a heartbeat from one of our apps. We create a task called heartbeat. We call our event. Like I said, this is a Callbox example, but this could be anything. That call can be anything. Every 5 minutes, and if there's a failure, right, I'm going to get my system instance, and I'm going to send a bad heartbeat with that exception. Right? And I'm going to log my bad exceptions. Okay? So now I've attached a listener right into my task definition that whenever that failure happens, that's going to execute. Right, lifecycle methods, really important, especially for the people that are going to be managing your scheduled tasks, right? How do I recover? How do I know what something went wrong? So you have an on startup. This is called after the scheduler has registered all the schedules. Okay? Like I said, all the schedulers can have many, not only one. On shutdown, there's cleanup that you can do. So when a scheduler is about to go down, you can actually intercept. On any task error, so this is called when any task fails in your entire system, it will be called. On any task success as well. Before any task, so you have the ability to intercept the task before it executes. And after any task executes, and you can see that you receive a result as well. So if your task actually produces a result, you will have access to it. Okay? So the tasks can have the concept of just being runnables, right? They just run, but there are tasks that are basically called callable, right? So they can actually receive an output, right? So here's some examples. I have on startup, I log it. I want to make sure that my schedulers are logged when they start up. And I have an any task error, and I have a beautiful task has bombed, right? And I put the exception, right? So you have control over these. Like I said, since now we're in a class, you can put more design patterns into it, right? You can create a base scheduler that has all the exception handling needed for your company in one format, right? And all your schedulers will inherit from it. So let's look at some configuration methods for as schedules are getting more complex. The first one is you can leverage a cache. So if you're in Callbox or in Boxlang, you can say all the registered tasks are going to be tracked in my cache. Okay? If you're using a distributed cache like Redis or Couchbase or Elasticsearch or Mongo, all your tasks are now going to be cluster aware. You can set the server fixation to always be true. By default, all the tasks will always execute on every server that they're on. But you can globally set the server fixation and say, hey, I want all my tasks to only execute once per server in my cluster. Okay? You can set a time zone. Painful, especially when we were working with multiple time zones, right? You can set the time zone for the global scheduler. Every scheduler can have its own time zone. Okay? And that's important. We really wanted to make sure that every scheduler had the ability to basically influence its time zone. Set the executor. We leverage all the concurrency packages in the JVM. If you know what you're doing and you want to create your own executor or use virtual threads in JDK 21, no problem. You just give me the executor you want me to use, and we're going to use your executor. Okay? Maybe you have a big machine, and all these tasks are super I/O computing, right? Then maybe you can give me an I/O computable executor that has a lot of more threads on it, right? So that was really important for us, especially doing different types of tasks. Okay? So here's an example. I can set my cache to Redis. I want server fixation for this scheduler, so that means that every task is only going to run once, no matter how they are in my application cluster. Okay? And the time zone. This is America, Chicago. Okay? All right, so those are some configuration methods. Then we start getting a little bit more of the tasking. Right? What do we do with it? Well, if you are in a Callbox environment, you can say, give me a setting. That will give you a setting from Callbox. If you're just in a normal standalone mode, right, Wirebox, Cachebox, Lockbox, or Boxlang, it will retrieve a setting from wherever you set. Getting an instance of an object, if you're using Wirebox, you can have access to the dependency injection framework. If you're in Callbox, of course, you can execute an internal event. You can run a route, right? So you can say, hey, go run this specific route. You can render a view, right? Right within your tasks. You can render a layout within your tasks as well, or combo, and do much more. So the rest you can build on your own. We just give you tiny little helpers for tasking. And an important one, announcements. So this taps into the interceptors, into Callbox, interceptors into Wirebox, interceptors into Boxlang, right? So you can actually start announcing events when tasks are being executed, right? So you can create progress bars, so you can have a listener in a WebSocket being able to do that, and we do that with our CBQ project. All our scheduled tasks are announcing asynchronous events, determining on where they are in the task. And we have a panel, and we're looking exactly at all the tasks, what they're doing, because we have the capability to do announcements. Okay? And in Boxlang, you also have another one called Announce Async. So you have all those capabilities at your disposal. The registration of tasks is very simple. It's one method called call. This is where you register the task. Here's an example, just calling an instance every hour. So call my service, run my cleanup every hour. Here's one every hour at minute marker 45. Right? Inside of that function or closure is your domain. You do whatever you need to do there. That is the code that's going to represent your task. You can instantiate a task, right, that you've encapsulated in another class, right? Up to you. It's your choice. Here's another one. Who can detect the difference here? Let's see. Trivia question. What's the difference here in the call method? Here. This is before. This is now. Who can see the difference? It's not in a callback function. Okay? So you have the option to use a closure or a lambda. There you go. a closure or a lambda, right, which delays execution of your code to execute it. But here you pass an instance. So the call method not only can detect if it's a closure or a lambda, it will detect if it's a component, right, any type of class. And then it says, okay, you gave me my task, right? So then it registered that task as your callable method, and then it must implement our interface, basically one method called run, right? As long as it has a run method, it works, okay? Now you can pass a second parameter and tell me which method you want me to call as well. And then I will call that method on that object for you. So you have options there for reusability. Here is example for the method. I say, hey, call the cache service object, the reap cache method, every day at 1 p.m. That's it. Scheduling times. So the call method is really simple. It's really up to you to do your scheduling. All right. There's a few time units, and like I said, we wanted to make it really human for you to actually read it and know what's going on. You can say, I want it to run every period with a time unit, right? Every 5 seconds, every 10 minutes. But you also have a spaced delay one. So this means that it will wait until a task finishes in order to put the period after that. So imagine if you have a task that says every 5 seconds, but the first task hasn't finished yet, right? It will try to bulk them, right? But with the space delay, you're saying, no, I want to guarantee that my task ends. So if it's a cache reap, for example, I don't want it to start another reap if I'm in the middle of a reap, right? So I say I want to start it with a space delay of 10 minutes. So every 10 minutes, I'm guaranteed that it will run once the other task finishes, right? Subtle difference, but important difference. You can use different time units, like I mentioned, days, hours, minutes, seconds, milliseconds, if you want it to be adventurous, microseconds. I'm sure somebody will find an excuse to use a microsecond. Nanoseconds. All right. I don't know why I did that one. Probably was bored that day, but exactly. No good reason. It's like it's there. It goes. But you have the capabilities. And that was our intent, to have all these capabilities. But we said, okay, let's do a little bit more human expressions. Okay, so we have our every methods. So you can say every day at a specific time, every minute, every hour at 1 p.m., every hour at 6 p.m., every day at 9 a.m., every week on a specific day or on a specific time, every month on a specific day and a specific time, right? And then business requirements, right? It has to be a first business day of the month, on the last business day of the week, right? Every year. Yes? You can set the locale. If you set the locale of what you give to Lucy, for example, we use whatever you have in the CFML engine. Yeah. But that's a good also a segment question, because first business day, how about holidays, right? Like I've learned in Spain is always on holiday. I don't understand. They have so much vacation. It's like my kids don't go to school as much. But question, right? How do you deal with that, right? So that's when you go into next levels, right? So we can do as much as we can here. The rest is really where you live and what are the holiday schedules that you want to address, and that's where the when expressions come into play. So if you move to Spain, you will have a lot of vacation. I don't know how it is in Germany. Weekends, more stuff. On weekends, on weekdays, right? On Mondays, on Tuesdays, on Wednesdays, etc. That fluent expressions for everybody that reads it knows exactly when the task is going to run. Like I said, one of tasks was really important for us. And the only thing you do is you don't give it a time. You basically can only delay it. So in this example, I say, give me an instance of my data services, and I want you to build up the cache when my application starts, but only after 1 minute. Delay the registration of this task for 1 minute, and when 1 minute passes, then my caches are starting to build up. Asynchronously. Remember, this is all executing in a vacuum. Okay? Now, we saw lifecycle methods globally at the scheduler level, but we also have them at the task level. So the task can also dictate what happens after it executes. Okay? You store a programmatic closure or lambda to execute whenever your task completes, before it completes, on failure, on success. Whoops, skipped it too fast. Hold on. There you go. 4 of them. Before, after, on failure, and on success. Okay? You store what is going to execute when those life cycles are being executed by the scheduling system. Here's examples. You make a call, right? I didn't write anything there, so I can put the code there. But before, right, you register your before, your after. You see the after receives results as well, okay? On failure and on success as well. Now, behind the scenes, the results are actually called optionals, right? Because it could be nothing, but actually it's an expressive object. So you can basically do operations on those results objects as well. Constraints. So we talked about now getting into the nitty-gritty of things that happen only on your environments. So here's something that I could do. I can say, I want to remove my thirst. So I'm going to call the drink servers to order drinks here hourly. I need my beer hourly. And when? When the drink service is on happy hour, because I'm cheap. Right? So I use a when expression. Right? So now this is your domain. It's whenever you feel that this task has the right potential to run, then give me my truthy value, and then we will address it. Here's another expression. So let's say that you want server fixation not for the entire scheduler, but only one task needs to execute only on one servers. Like, let's say cleaning out old users. I'm going to be touching the database. I don't want, in my cluster I have 50 servers. Why do I need 50 servers going to my database to clean old data users, right? So I say, hey, call the clean old users daily on one server only. Which one? Don't care. Just as long as one can run them, run it. Okay. Here's environment. So I can say the same deal. Okay, I only want to clean old users when I'm in production or staging. So here I can say on environment. Which environment? And you can pass a list. Okay. Now, granted, this is for Callbox, or you build your own environment detection. The default time. Yes. Midnight. Yes, that's in the docs as well. So if you don't care about the time, let's say like cron, you can say daily, and it will pick a time, usually midnight, right? The same. Good question. Yeah.
Question, you said it's bound to Callbox when it comes from the environment. Could that also be an environment variable or something it can read? Or
yes, you can do the when expressions as well. So when we're in Callbox, I can give you a little bit more things, right? So when you're in Callbox, I know a little bit more about your app, so I can give you more. But if you're not, then it's really up to you to decide what to do. Yeah. Now we said, okay, great, all our tasks are working. How do I know, right? I don't want to sit there and look at a log file, right? So we introduced statistics. So you also have statistics of your schedulers. You know when things are created, so the timestamp of when the task was created in memory. The last run, so you know exactly when that task actually executed. The next run was also important. We tell you exactly when that task is going to run again. The total failures, how many times this task has failed execution, how many runs it has had, how many times it succeeded, And then we can start building ratios for your tasks. So we have a getStats method. So you can say, hey, scheduler, so I can get an instance of my scheduler, because they're stored in Wirebox. Okay? If you're in standalone mode, you're using probably Wirebox, so you can get access to your scheduler, and say, hey, give me the task record for this task. And you're going to get the task record, and then you can say, give me the statistics about that task. And this was important for us, is that you have a programmatic way to talk to your schedulers, even if they're running in Ether, right? But you can still get access to them and be able to get information out of them. Not only can you get stats, but there's other things I didn't show here, but you can get their last results. Okay, I want to inspect the last results. I want to see a trail of how things have been behaving. And you get all that information. Yeah, they're all stored inside of the scheduler. So a scheduler instance contains its own state. Yes. Unless you cache it. Or wherever you want to put it. Yeah. So you can add a listener. We have, for example, on our cluster, we have these statistics going to our database, right? And then we have an aggregate view, right, of schedulers, how they're behaving on each of the instances, right? Because this is a snapshot view of one scheduler. Okay? But we said, okay, this is great. I'm like a kindergarten kid. I need to see pictures, and big ones. So we did one. So we said, okay, let's build an administrator, right? So let's look at how I can manage my tasks. So we have, this is open source, by the way. You can collaborate and help. This is the initial beginnings of this. We also have a pro version in CB Debugger coming soon. They'll give you a lot more things. But you have a UI. So you can see which module contributed, okay? Which executor is using, the grouping, the task, when it started, the last run, the next run, what time of period or time unit it's using, what was the last execution time, how many runs it has. But then I can pause it. I can say, look, you know what, I don't want this task to be run right now, pause it. So I can pause it. I can delete it. You know what, I don't want this running in memory right now, and I can delete them from memory. If I restart, they come back, right? Yes?
Okay, pause means it's in memory. So if you restart the server, it will restart the task.
Yes.
While you persisted in database or
This is persisted in memory for the moment.
yeah.
The pro version will allow you for persistence. Okay? Yes?
I think a scenario when your task will not be started. We encountered it.
Yeah? Then you basically don't treat it as a one-off task, and then you, or sorry, there's a disabled method.
When will your scheduler be started?
The scheduler or the task?
No, the scheduler. When will your scheduler be started?
Okay. I'll have to look at all the methods that you have available to it.
Will be started if your application has been initialized.
Correct.
So if you have, for example, we had scenarios where people were using the server at daytime. We were updating the server evening, restarted the server, and if you don't have any external thing in place which hits application,
Ah, I get you. Yes, yes. So,
we had it many times in the beginning, and then I realized if you restart the server, you should have some external scheduler or keep a live process
correct.
to make sure your scheduler is started again.
Yes.
And that's no problem at all. That's a big difference between this kind of scheduling and the scheduling if you have Confucian scheduler, it will always start, and your scheduler will only start if your application is active.
Half true, because now we have a hook into the JVM called JVM hooks. So you can hook when the JVM starts and when the JVM stops. So that's in the BE. So now it doesn't matter. As long as the application starts, the server starts, it will listen to the JVM. So it's coming, right? But I also need to talk to him to give me more hooks. So, yeah, so I need to know how I can listen as well.
We had monitoring on most of our servers, so most of the time it was hit within 1 minute, but if you don't have
Yep.
it, you have a problem.
Yes, that was a problem. There are ways to resolve it, but yes, I want to find a way that I can just tap into the engine and say, hey, engine, I need to start me up when you start, right? Without going through loops. But good point. But that's the idea. The idea is to give you a nice visual tool so you can actually be able to know what's going on and give you a little bit of interactivity. Okay? Yes? These are for the local tasks, yes. For anything that it has available to it. Yeah. Yes. Yeah. So there will be a lot of dev tools that are available open source for free, and then whatever we feel could be more useful, more enterprise, then you have to pay my lunch. But yes. Yeah. Yeah.
How does the cluster communication work? How does a server know another server already started?
Well, if you tell me which cache it is, then I talk to the cache, and that's my distribution layer, right? But for example, if you use CBQ, which is another project that we have, right? Then it uses either WebSockets or ports or whatever to do intercommunication, right? And then you can do your own, up to you. So, but that's always a problem, right? That you have to solve. Yeah. I guess I don't have time for the demo, but I'll point where you can find all this demo code. So if you go to github.elmahano, there is repos. This one. I'll leave it there for a moment. Okay. It has tons of schedulers there, a lot of examples. It has the scheduling UI, so you can start working with it. It comes with 3 flavors. It comes with an Adobe server, a Lucy server, and a Boxlang server. And then you can just basically try them out, right? Start working with schedules, seeing how the UI helps you. If you have contributions, things you want to make this better, go for it. Like I said, our scheduling applications have been inside of Coldbox since version 5, right? They're very mature at this point. Now that we're in version 7. And we're adding a lot more functionality into it. And everything that's available is already available in Boxlang as well. So you can create your own schedulers, and I don't have that problem because I can control them. But we have 3 minutes? 2? Right, more questions. Yeah.
I know there's the version schedule in the product, but can I also do it without scheduling? That means, let's say I have a queue with tasks, and I want to say, okay, I have a cluster with 10 servers, and I just want to say, just pick jobs from the queue.
Yes.
And I don't care, and maybe I start 20 servers, and they start to take
Tasks.
jobs from the queue, and as long as they are jobs, they're working.
Yes.
If there are jobs, they stop until there are again jobs.
Yes, that's exactly what the CBQ project is that I was telling you yesterday. That's exactly what they do. They basically leverage this to just have the workers, we call them, right? So it basically creates workers with this, and then basically you're sending tasks. And it uses the database, or actually it has a provider, so you can use whatever you want, and you do exactly that.
But that's project from Peter.
Yeah, it's right here. I'll show it to you. CBQ. It's called CBQ. So it's a protocol-based queuing system. Oh, it looks terrible. Oh, what did I do wrong? Oh, I was zoomed. Ooh, that looks tiny. All right, better. Right, so this is CBQ. It's a module for protocol-based queuing. Okay, like I said, it's almost 3 years now. You can define jobs, create jobs, dispatching job, working jobs, tons of stuff, tons of configurations that you have for your work pools. You can use a database provider. You can use the Coldbox async provider for in-memory, right, or a synchronous provider. So you have all kinds of capabilities, custom providers. We built the WebSocket provider, Redis providers. This is now we had that ability to do all these things because of the scheduling framework. So all this is available. Again, it's a Coldbox module, but we're bringing this also as a module to Boxlang as well. But it's there, and that's exactly what it does. It's basically providing queuing, protocol queuing, and workers. Okay. Yeah.
What is the license?
$1 million. It's Apache 2. The what? 2 million. No. Any other questions? Yes.
Is there something like to restart a task? So once finished, you just go over and start again? Is that
Yeah, the tasks is basically a repeatable execution, right? So,
I don't want to any like I want to run it till whatever internal queue says I'm done. So
oh, for the queuing, you mean?
I can only run batches of whatever
Ah, okay.
elements and then
So that would be CBQ. So this was, you can say, the queues can actually shut down if you want, right? So if they have inactivity, out of time. We can talk later before Mishi gets violent. Thank you guys, appreciate it.